will discuss how these equations will be written in phasor form. For that, a simple modification will be there. Just you remember, for phasor form, the frequency will be taken into the picture. For that, what I do is I will consider the electric field and magnetic field in their phasor notation. So let us take E is equals to E naught e power j omega t. In the same way, the magnetic field H is equals to some H naught e power j omega t, where E naught and H naught are the some magnitudes of electric field intensity at time t is equals to 0. Right. So differentiate them with respect to time. So dou E by dou t is equals to, so E naught, it's a fixed constant. So dou by dou t of e power j omega t. So which is equals to E naught j omega e power j omega t. So j omega E naught e power j omega t, that what we have here, that E naught e power j omega t once again can be replaced with E. So which is equals to j omega E. So if you do the same analysis for magnetic field also, what we get is here dou H by dou t is equals to j omega H. Just observe, clearly dou by dou t of E is equals to j omega of E. Here dou by dou t of H is equals to j omega of H. So from the observation, what we can say is the operation dou by dou t, differential operation, that what we are considering, and the operator dou by dou t can be replaced with j omega to convert or any equations into the phasor form. So nothing more than this except this simple change. So whenever you find dou by dou t, replace that one with j omega, then all the equations will be converted into the phasor notation. So one by one, for our convenience, as I said, the differential equations can be converted into the integral equation. But for our simplification, what I do is I will try to explain all the differential equations only. So right, so what I do is I will take the differential equations which are meant for our time varying fields, and so I will replace this operator with j omega, then they will be converted into the phasor notation. So left hand side I will write the time varying equations which are in normal form, and then right hand side I will write them in phasor notation. So one by one, what are the equations that what we have? The first equation, I am writing them in the differential form only, right? The first equation is del dot d is equals to rho v. That is the equation that what we have. Clearly observe, there is no dou by dou t term. So in phasor form also, that here after arrow mark on the right hand side I will write down the phasor form, that this is also equals to del dot d equals to rho v. There will be no change. Clearly del dot d is equals to rho v is also applicable for phasor form. The same way, second equation, del cross E is equals to minus dou by dou t of B. So this is the equation that what we have for time varying fields. Now clearly we can modify this equation which is suitable for a phasor form, that this dou by dou t operator can be replaced with j omega. Just now we discussed that one. So now this equation can be written as del cross E is equals to minus j omega B. And clearly observe, B can be written as mu h, that there is a relation between B and mu, B and h, that this j omega mu h equation is a suitable equation for our phasor form. In the same way, third equation, that what we have is del dot B is equals to 0. Since there is no time varying term here, this equation can be as it is written here, that del dot B is equals to 0. There is no change in this one. In the same way, fourth equation that what we have is del cross H is equals to J plus dou d by dou t. Now once again clearly observe, here we have a dou by dou t term. This dou by dou t operator can be replaced with j omega. So this equation can be written as del cross H is equals to, now J can be written as, so that J is conduction current density, that what we discussed. This J can be written as sigma E, that is conduction current density, plus dou by dou t operator can be replaced with j omega, and D can be replaced with epsilon E. Just what I am doing is I am modifying these terms. J is replaced with sigma E, and dou by dou t is replaced with j omega, D is replaced with epsilon E. So which is nothing but simply sigma plus j omega epsilon multiplied with E. So these four are the four Maxwell's equations which are mentioned in our phasor form. That clearly take the time varying field basic equations. Don't go for any other, don't remember them. Just take the basic equations and modify these equations according to the requirement. As I said, so by applying divergence theorem and Stokes theorem, inverse of this one, so clearly you can get the integral form of these equations. You can write down them by applying them as an assignment. Now we will discuss these Maxwell's equations in all forms, that is for static, time varying fields and Phasor notation, and which are applicable for free space. So because our wave propagation or the radiation is purely related to our free space, so we are supposed to discuss this special case, that for free space how these equations will be written. That what I do is I will try to take the static fields, time varying fields and Phasor notations, and I will try to modify them by applying the conditions which are meant for our free space. So before that, just let us discuss so what is free space, what are conditions for free space. So clearly remember that whenever we have free space case, free space has no charges, that the charge density in free space is equals to 0. Whatever it may be the charge density, that may be line, surface or volume, but here clearly remember the free space will contains volume charge density has 0 value, right? So clearly you can write rho v is equals to 0, a volume charge density 0, and clearly once again the free space contains no conductivity. Since it has no conductivity, 0 conductivity, sigma must be equals to 0. That what we are supposed to take. And what about the relative permittivity? The relative permittivity of the free space is always equals to 1. So epsilon r must be equals to 1. That what we are supposed to take. Mu r, the relative permeability of the free space, that also must be equals to 1. So mu r is equals to 1. Just for free space, remember these 4 equations. Later, if it is required, we will try to modify these equations by taking some other condition for some other medium. But free space is a very, very important medium, that what we are supposed to analyze. That's why remember that there will be no charges in space. Since there are no charges, conductivity is equals to 0, and the relative permittivity and relative permeability, so these two must be equals to 1. Now, so initially I will start our discussion with static fields. So I will write down, so once again I am saying I will write down the differential form of equations only here. So you can write the integral form later. So differential form of equations for static fields. So what is the equation that what we have? The first equation is del dot d is equals to rho v. This is a basic equation, right? But here clearly for free space rho v is equals to 0. So how this equation will be modified? Which corresponds to del dot d is equals to 0. Since del dot d is equals to 0, what you can interpret from this one? There is no diverging electric flux density. There is no diverging electric flux density if the medium is free space. Nothing more than that. And if it is linear medium, how you can write this one? Del dot epsilon naught epsilon r e is equals to 0. That what we have, d is equals to epsilon naught epsilon r e, right? So epsilon r is equals to 1, which corresponds to del dot epsilon naught e is equals to 0. And clearly remember, whenever we are considering free space, it is a linear medium, that the epsilon what we are considering is does not depend upon the space. So this can be written as epsilon naught del dot e is equals to 0. Clearly epsilon naught is a constant, it is not equals to 0. Therefore from the compilation what you can say is del dot e is equals to 0. That clearly del dot d is equals to rho v is the basic equation that what we have for static fields, but that was modified as del dot e is equals to 0 and can be treated as Maxwell's first equation for free space. So whenever you are asked to write down that del dot e, Gauss law for electrostatics in our free space medium, just you need to write down this del dot e is equals to 0. In the same way, what is our second equation? Our second equation is del cross e is equals to 0. So it's clearly for static fields del cross e is equals to 0, and observe there is no modification here. As it is, we are supposed to remember this equation for free space also. So del dot e is equals to 0 free space, del cross e is equals to 0 for free space. So clearly observe these two. The electric field is irrotational, that what you can say from this del cross e is equals to 0. Del dot e is equals to 0, the electric field is solenoidal. So the electric field in free space is irrotational as well as solenoidal. That what you are supposed to remember. And the third equation, that del dot b is equals to 0. Now B can be replaced with, this can be written as del dot B is mu naught mu r h is equals to 0. And once again observe, what is this mu r? Mu r is equals to 1. So this can be simplified as del dot mu naught h is equals to 0. Now we are considering a linear medium, that's a free space, that what we are considering is a linear medium. Therefore this can be written as mu naught del dot h is equals to 0. Since mu naught del dot h is equals to 0, clearly mu naught is not equals to 0, we can say that from the compilation, so the compilation of these two, del dot h is equals to 0, that this is the equation what you are supposed to remember for free space, right? In the same way, the fourth equation, that what we have is del cross h is equals to j. For static fields, clearly del cross h is equals to j. But what is the relation between j and sigma? So we have a relation that j is equals to sigma e, that del cross h is equals to sigma e. But what is the conductivity of the medium? Conductivity of the medium is 0. Since conductivity of the medium is 0, what we can write here is del cross h is equals to 0. So just you observe what are the equations that what we found for static fields in free space. Del dot E is equals to 0, del cross E is equals to 0, del dot H is equals to 0, del cross H is equals to 0, del dot H is equals to 0. So clearly del dot E equals to 0, del dot H is equals to 0. So E and H are solenoidal. Del cross E is equals to 0, del cross H is equals to 0. H is irrotational, E is also irrotational. So these four are the conditions that what we are supposed to remember whenever you are asked to write down the equations for free space. Now we will discuss them for time varying fields. For the free space, how the time varying equations will be modified. Right. So now we will discuss about the time varying fields in free space once again. So what is the first equation? For time varying fields also in the differential form, del dot D is equals to, now here it is rho v, the same equation, but rho v is equals to 0, which corresponds to the same analysis there also we are supposed to do. It's okay. So it's simply it is del dot E is equals to 0, that what we get for time varying fields. So for static fields as well as time varying fields, the equation will be unaltered, it will not change. And come to the second equation, del cross E is equals to minus dou b by dou t. Since we are considering a time varying field, it is del cross E is equals to minus dou b by dou t, right? Since we are considering minus dou b by dou t, del cross E which are in free space, this B can be replaced with minus dou by dou t of B is equals to mu naught mu r h, that mu r is equals to 1 and mu naught can be brought out. So it is minus mu naught dou h by dou t. This is the equation that what we are supposed to remember. So simply del cross E is equals to minus mu naught dou h by dou t in free space. Just remember the equation, we are supposed to interpret this one. Next, third equation, del dot B is equals to 0. Same, del dot B is equals to 0 for free space also, that will be analyzed, and from this one what we get is del dot H is equals to 0, that the diverging magnetic field intensity is also always equals to 0. And the fourth equation that what we have is del cross H is equals to, clearly you are supposed to write down this equation for time varying field. For the time varying field, it is J plus dou d by dou t, that J plus dou d by dou t can be written as sigma E plus dou epsilon naught epsilon r E by dou t, that D can be replaced with epsilon naught epsilon r E. Now once again observe here, sigma E, that what we have, sigma is 0 for free space. So since sigma is 0 for free space, this term can be vanished. And what about this epsilon r which is equals to 1? So clearly the right hand side term can be written as epsilon naught dou E by dou t. Simply this is the modification that what we have. Now once again compile them. Del dot E is equals to 0, which means the diverging electric field intensity does not diverge. del dot H is equals to 0, the magnetic field intensity also does not diverge. But del cross E is equals to minus mu naught dou H by dou T. Del cross H is equals to epsilon naught dou E by dou T. So what are these two equations? The curling of electric field is existing. The electric field has a rotational nature. So whenever there is a time varying magnetic field intensity, the electric field will exist and it has rotational nature. And here come to this equation. Whenever we have a time varying electric field, the magnetic field has a rotational nature. So clearly, if you interpret it in a simple way, that varying electric field can generate a magnetic field perpendicular to it, and a varying magnetic field can generate an electric field perpendicular to it. How we can say that it is perpendicular? Clearly observe the result. Del cross E is equals to a varying magnetic field. That the cross product of two vectors can generate a third vector which is perpendicular to both. So here the result what we are getting, a time varying magnetic field is perpendicular to E. Here also a time varying electric field is perpendicular to H. So in general phenomena, always you are supposed to remember that whenever we have electric field, if it is time varying, a magnetic field will be there. Whenever we have a magnetic field, if it is time varying, electric field will be there. And clearly the direction, it's the electric field, if it is the electric field like this, then the magnetic field is perpendicular to it. If the magnetic field is like this, then the electric field is perpendicular to it. So always in our free space or whatever it may be the medium, the general phenomena is electric field and magnetic field are perpendicular to each other. And if it is a time varying phenomena, then definitely you can find these two. So this is our time varying equations which are meant for free space. Now the third modification is for the free space. Same free space, what we do is we will try to modify our Phasor notation also. Now in the Phasor form, how these equations will be modified for our free space? That consider the first equation, that del dot D is equals to rho V. So del dot D is equals to rho V corresponds to del dot D is equals to 0, since rho V is equals to 0, which corresponds to del dot E is equals to 0. So even though we are considering that one in Phasor form, what we are getting is del dot E is equals to 0. So blindly remember, whatever may be the medium, if it is charge free region and linear, del dot E is equals to 0 is applicable. So whether it is time varying, static or Phasor notation, if it is considered for free space, del dot E is equals to 0 is only the equation you are supposed to remember. The second equation, del cross E is equals to minus j omega mu h. That's this mu h can be written as minus j omega mu naught mu r h. As we discussed, this mu r is equals to 1, right? So simply this equation is now minus j omega mu naught h. So this is only the equation that what we are supposed to remember in Phasor form. That simply this instead of this mu r, substitute 1 there, nothing more than that. And the third equation, del dot B is equals to 0. As we discussed, this del dot B is equals to 0 corresponds to del dot mu h is equals to 0, which corresponds to del dot h is equals to 0. So del dot E is equals to 0, del dot h is equals to 0. These two equations will be unaltered, whatever it may be the form. And the fourth equation, del cross h is equals to sigma E plus, here it says that what I am writing in Phasor form, that is j omega epsilon E. So this is sigma E plus j omega epsilon E, that what we are considering for free space. Since we are considering for free space, sigma must be equals to 0. So this term will be equals to 0, and this epsilon can be written as j omega epsilon naught epsilon r E. Epsilon r is equals to 1. So therefore this equation can be simply written as epsilon naught j omega E. So just observe a very simple modification, that we are not supposed to take any complex equations, nothing. Just we are supposed to replace the terms what we require with the relevant terms. Here for Phasor form, dou by dou t will be replaced with j omega, and that Phasor form equation is observed for free space. Since we are observing for free space, rho v is equals to 0, sigma is equals to 0, epsilon r and epsilon mu r, these two will be replaced with just 1. So the four equations that what we have, so these four are meant for our free space and which are written in our phasor form. Like that, we are supposed to modify these equations, or we are supposed to write these equations for any type of medium. That if we are taking a conductor, we are supposed to keep this sigma as it is. We are not supposed to make this equals to 0. For conductor, the sigma will exist, and for any other type of medium, if there is mu is equals to mu naught, we are supposed to take mu is equals to mu naught, but keep epsilon as it is. Like that, what we have to do is we have to modify these equations whenever you have some boundary, or whenever you have some specific problem. So clearly remember, whenever we are writing these equations, just remember the basic form, that's a differential form of equations which are meant for time varying fields, and try to modify these equations according to the requirement. So these 4 equations are very, very important equations we are supposed to remember. Now what we do is we will try to solve few problems which are related to our Maxwell's equations.